Hi class, today we're looking at Chapter 5, Lesson 8, Scale Drawings and Models. What we will be learning today is how to use scale drawings and how to construct a scale drawing and scale model as well. A scale drawing or a scale model is used to represent an object that is too small or too large to be drawn or built at actual size. The lengths and widths of the model are proportional to the lengths and widths of the actual object. So in other words, we're using different units of measure. So if we have a drawing that's measured in inches, in real life we could take that image and create it in feet. Now the scale is determined by the ratio, a fraction, of a given length on the drawing or model to its corresponding length on the actual object. So for example, if we have our house that has the height of so many feet in real life, but the smaller the scale in our drawing is 8.5 inches, we know in real life that a house is not 8.5 inches tall. It's going to be measured in feet. It's going to be taller. So what we do, we have to be given a scale factor. A scale factor is a conversion from what is in the image. So for every 2 inches in real life, it's 5 feet. And that's where we create our ratio, 2 inches over 5 feet. Now we take that and we create a proportion of information that we're provided with. So in this case, we are given the 8.5 inches of our scale drawing, and it's equal to the 2 inches of our scale factor. Now the 5 feet is what it's going to be measured in real life as the scale factor. But we need to know how many feet it will be in real life. So we are actually looking for this part right here. And we set up the proportion. And the way we would solve it is how we would typically solve proportions. You use cross product. So we can multiply 2 times x, which is 2x, equals 8.5 times 5. So now 2x equals 42.5. Then we divide each side by 2. And this leaves us with 21.25 feet. So the height of the real life house would be 21.25 feet tall. Now let's go ahead and turn our notes over to the backside now. In example 1, suppose a model of a dragonfly has a wing length of 4 centimeters. If the length of the insect's actual wing is 6 centimeters, what is the scale of the model? So in this case, we have our dragonfly that has the scale factor, or scale, of 4 centimeters. That's the model. The actual size would be 6 centimeters. So in this case, we are creating the scale factor, which then can be simplified by dividing by 2. And we end up we divide each one by 2, so we end up with 2 centimeters for every 3 centimeters. So this would be the model, and then this would be the actual. Now this is considered your scale. So our actual scale of measurement would be 2 centimeters to 3 centimeters. In example 2, the pillars of the World War II Memorial in Washington, D.C. are 17 feet tall. A scale model of the memorial has pillars that are 5 inches tall. What is the scale of the model? So when we're looking for the scale, we just want to know what it can be converted to. So in this case, we're going to divide by the 5, top and bottom. And once I divide by the 5, top and bottom, I realize that it ends up being a scale of 3.4 feet, which is the real life, the actual, for every 1 inch. And that would be considered the model. So now what is the scale of the model? It would be for every 1 inch, it is 3.4 feet. Now go ahead and try this problem on your own. Remember, you are simply just looking for the scale, and that is just creating the ratio. Now, when we're provided with the scale factor, if the scale drawing and model have the same unit of measure, the scale can be written without units. This is called the scale factor. So the blueprint of a skateboard ramp shows that its length is 11.4 inches. If the scale on the blueprint is 1 inch equals 6 feet, what is the actual length of the skateboard ramp? So in this case, we are given a scale factor of 1 inch for every 6 feet, which means if I know that the actual ramp in the blueprint is 11.4 inches, but I don't know how many feet that would equal in real life, that is my variable. So I set up the proportion, and now I can evaluate. So in this case, I know I'm going to multiply 1 times x, which is 1x. Then I'm going to multiply 11.4 times 6. And once I multiply the 11.4 times 6, I end up with an answer of 68.4 feet. And that ends up being my blueprint or the actual length of the skateboard. So this is the actual length of the skateboard ramp. And that is my final solution. So in real life, it'd be 68.4 feet. Now, in example 2, a map of a museum shows that the dinosaur exhibit room is 7.25 inches wide. If the scale on the map is 1 inch equals 8 feet, what is the width of the actual exhibit? So now in this case, we're given 7.25 inches, and then we don't know the amount of feet for the actual exhibit. But we do know the scale is 1 inch over 8 feet. So now we're going to use cross product again, and we get 1x equals 7.25 times 8, and we end up with x equals 58 feet as the actual width. Now, in our last got it problem, you're going to have on a map the scale of 1 inch equals 20 miles. If it shows that Kansas City is 13 inches away from St. Louis, what is the actual distance? So don't forget, you are creating ratios and you're setting it up as a proportion to evaluate. Go ahead and do the got it problem on your own.